Greetings and welcome. In a previous video session, we have seen a numerical in order to calculate the viscosity of oil, which is placed in a different applications. In this video session, viscosity of the oil is given and we have to calculate torque and power. The application is shaft rotating in a bearing. So let us see the statement of the numerical. A 400 mm diameter shaft is rotating at 200 rpm in a bearing of length 120 mm. If the thickness of oil film is 1.5 mm and the dynamic viscosity of the oil is 0.7 Newton second per meter square, determine torque required to overcome friction in bearing and power utilized in overcoming viscous resistance. First of all, we will understand the diagram of the said situation. So here, as per the situation, this is a shaft which is rotating in a bearing. In order to increase the life of the shaft or in order to reduce the friction, oil is used as a lubricant. Now the data which is mentioned in the numerical, that is mentioned here under the title given data. Shaft diameter, that is a D, in a mm is given, we convert that into meter. Speed of the shaft, that is a rpm, n number of rpm, 200 are given. Length of a bearing is given with a letter L, that is in mm, that also we convert into meter. Thickness of oil which is placed here, that is a dy, is given in mm, convert that into meter. And viscosity, dynamic viscosity of this oil is given in Newton second per meter square. Now in this numerical, we are going to calculate torque and power. So power is calculated with the help of formula, that is a 2 pi nt by 60, where torque, first of all we have to calculate, and torque is a product of force into distance, means we have to calculate force, that is a resistance offered by the oil. So this force is associated with Newton's law of viscosity. So let us see the further step. Now, as the Newton's law of viscosity is a shear stress is equal to mu into d upon dy, we have to find the elements of this formula. So that is why first of all we calculate the speed of the shaft in meter per second. So we use the relation between rotary speed and linear speed, that is u is equal to pi dn by 60. Here putting the value of diameter of the shaft in meter and speed in rpm. After the calculation, we find the value of du, that is a change in velocity in meter per second. Then we use this value here to calculate shear stress acting on the shaft. So we put the value of given, that is a dynamic viscosity here, calculated value of du we put here, and oil thickness in meter dy we put here. After the calculation of this, we find the shear stress in Newton per meter square, which is acting on the shaft. Further, to calculate force acting on shaft, we know that shear stress is equal to force divided by surface area. Now surface area is a lateral area of the shaft, that is AS. So here this equation we arrange in the form of force, as we have to calculate force. So force is on left side, on the right side tau into surface area. Further, surface area for the cylindrical shaft is what? This is a shaft with a diameter d and length L. So surface area formula is what? Circumference of the shaft, that is a circular circumference pi d into length L. So pi dl is a surface area. So now putting the value of shear stress calculated over here and other pi, then diameter is given and length is given. So doing this calculation, we get the value of a force which is acting on a shaft in Newton. By using this force value, we now can calculate the torque which is required to overcome the friction in oil which is placed in the space provided. So this is a shaft. So here we can see the concept of torque. Torque is what? Product of force which is applied at the circumference and distance from the center, that is radius. So force into radius is what? Torque. Further, this radius can be mentioned in the form of diameter because we know the diameter in the statement. So putting the value of force which is calculated in a previous slide in a Newton, given value of diameter, after doing the calculation we find the value of torque, that is in Newton meter. Then we calculate power utilized in overcoming the resistance which is offered by the oil. So formula for that, P is equal to 2 pi nt by 60. So here 2 pi into n is a speed in RPM given. Torque we have calculated here in Newton meter divided by 60. Doing the calculation, we find the answer. This power is in watt. This power we can express in kilowatt. So for that we divide this value with 1000. Thus we find this value in kilowatt. So this was the procedure to calculate the torque and the power of the concept, that is a use of oil in a bearing which is with shaft rotating inside the bearing. Let us meet in the next video session. Thank you.